today's webinar. Today, we're going to be talking about building bridges, not silos. This is an update on the Semantic Bridge feature in Tabular Editor. My name is Greg Baldini, and I'll be your host for the day. Before we dive into the presentation and the demos and all of the good stuff, a few things to mention up front. This webinar is being recorded. It'll be available on demand later after the webinar is completed, and you'll receive a link to be able to get to that. All of the content that we'll be showing, the slides, all of the code, every example that we're looking at will be made available as well, again, after the webinar is completed. Please feel free to engage in the webinar as we're going through. We've got a chat in the application. We've got some colleagues that are moderating that chat and watching for questions. There's also a Q&A feature in the application. So please, if you've got any questions that you'd like answered during the course of this webinar, use that question feature, and we'll answer some of those in chat directly, and some of them we'll curate and I'll answer live at the end of the session. So feel free to engage in chat or questions. All of those will come through, and we'll make sure you get an answer. And as we're getting started off, make sure to sound off, say hi, make sure you can actually use that chat. And before we dive into things, I've got a quick little poll just to see what people are using and what sort of environments they're working in. Just let us know which semantic layer you're using, whether that's Databricks metric views, whether that's Microsoft's semantic models, if you're using both, or if you're using some other semantic layer. And that poll should be popping up in the webinar application right now as we're going. And with that out of the way, we'll dive right into things. So to start off with, we've got a few questions to answer. First, who? That's me. Like I said, I'm Greg Baldini. I'm a core developer with Tabular Editor. I've been the lead designer for the Semantic Bridge, and I work on some of our language support features and parsers within Tabular Editor. And from time to time, I've been known to contribute some scope creep to our work. With me out of the way, we'll get into the meat of things. So what is the Semantic Bridge? Why might I want bridges instead of silos? So the Semantic Bridge is the name for a feature that we at Tabular Editor have developed. This feature is a framework. It allows model-to-model compilation. And we'll dive into exactly what all of this means as we get into the demos. But it allows us to take a model that is defined in some specific language or some format, and then we can take that and put it into a different format. So it takes two different models that represent the same thing and serializes them in different ways. We've got an implementation of metric view to Microsoft semantic model compilation with SQL translation as well. So we look at the measures that are defined, we look at the SQL expressions, and we actually translate from SQL to DAX. We've also got object models for these semantic layers. And again, we'll dive into what each of these things is and what they mean as we move through this. Why did we feel a need to introduce a new feature, this semantic bridge? What is it trying to solve? Why are we doing this? And the answer to this one of why is that as we've seen organizations mature in their data practices, a lot of organizations start adopting multiple platforms. There are very few large organizations that we've seen that actually have a single data platform. There are many different databases, sometimes multiple data warehouses, sometimes different data lake and data warehouse platforms in combination. And so because we've seen so many organizations adopting multiple platforms, there is this need to be able to share logic and be able to share the semantics, the meaning of business aggregations across these different platforms. The promise of every semantic layer, whether that's an original multidimensional OLAP cube, whether that's the analysis services model in Tabular, a Power BI or a Fabric semantic model, which are the same underlying engine, or if we're looking at Databricks and their metric views, or Snowflake and their semantic layer, all of these different vendors have this promise of define your metrics, define your business aggregations once, and be able to reuse them across reporting tools, across different analysts and different users. And as we're moving forward in time, also allowing AIs to take advantage of some of that rich metadata that's contained within a semantic layer. And these different data platforms that we see organizations adopting, each of them defines their own semantic layer with different formats and different capabilities. And so we've seen this need for interoperability to be able to use that one semantic layer and really achieve the promise of being able to have the definitions in one place and reused in many different other places. We've also seen that there have been a number of data virtualization approaches throughout time where you have data living in one platform and then other platforms kind of translate on the fly to do query against that data source. And what we've seen is that the performance really is best if you use native storage formats and you have the data local to the engine that's querying it. So things generally work better if you query a metric view directly from Databricks. And they work better if you query a semantic model in Power BI or in analysis services directly against that in-memory storage of the tabular engine. And so if we really want to achieve that performance, but we also recognize that things are defined in multiple places, what we end up needing to do is being able to take a definition that's defined once and reuse it. And that's what the semantic bridge allows us to do. Because we compile from one model format to another, you can define this in one place, for example, a metric or a measure in a metric view, and then use that natively in Power BI. And we'll look at what that import looks like. So how does it do all of this? I've made some promises and said what we're trying to achieve here. But the important question, what we really want to get into is how does the semantic bridge achieve this goal? How do we actually take a model that's defined in one place and move that over to another place? So this is a multi-phase approach, and there are ways that you can interact with this at each of the phases. And as we get into demos, we'll break down exactly what each of these phases is and how we can use them. So the first phase is ingestion. If we've got metric view that's defined in a YAML format, we'll look at a couple of those. We need to be able to read that model in. We deserialize from the serialization format from that YAML. We do some validation to make sure that it is a valid metric view. And then we've got a mapping phase. For mapping, what we do is we take the input platform format, in this case, a metric view. We take it through our internal mapping layer where we've got this abstract model, and then we output to the destination platform's format, in this case, the Microsoft semantic model. Along the way, what we do is an analysis of every expression, so all of the SQL expressions in a metric view, and we take those and we translate those into DAX so that you end up with the structure, every column, every field that's defined, every table that's referenced, every measure that's defined in the metric view gets an equivalent object that's created in the semantic model. So then Power BI and other client tools that know how to work with Microsoft's semantic model can query that natively. And then you can import or use direct query directly against those sources. So where does all of this live? There are a few different ways that you can interact with the semantic bridge. In terms of platforms, there's Databricks metric views are supported today, and we're looking forward to identifying what other semantic layers we'd like to support as we go forward. Databricks for ingestion, so we can read a metric view definition. And for output, we're targeting TOM model. That's Microsoft's semantic model for analysis services, tabular, Azure analysis services, Power BI, and Fabric. All of those share the same underlying model format. And so you can come from a metric view, go to any of those TOM output targets. In terms of how you can use the semantic bridge and where you're able to take advantage of it, that's within our products. Tabular Editor 3, it's available both in our Enterprise Edition and in our free trial. So if you'd like to kick the tires or try any of the things that you've seen here today, you can take that free trial of Tabular Editor 3 and do exactly what you're going to be seeing here. We've also got it available in our CLI, which is currently in public preview. And while the CLI is in public preview, the semantic bridge is available in it. The licensing for the CLI is still to be determined. So in the future, some of that might change of what tiers or editions it's available in. But you can download the CLI for the preview right now. And again, you can take advantage of the semantic bridge and follow along with any of the demos that you've seen here today. So those are ways that you can get started with the semantic bridge. Now, I usually don't like to do slides too much, so this has been a fairly quick introduction, but I'd really like to show and give some examples of what the semantic bridge is, how we can use it, and that'll really drive most of the rest of the time that we're spending here together until we get to that Q&A. So I'm just going to switch the screens that I'm sharing really quickly. And I'm going to come over to a tabular editor window. So here we are looking at tabular editor. And we'll start simply with an empty model. I've got this open, but I don't have any models in here. And what I want to do is be able to get a metric view. So I've talked about a metric view, and I've said what it is and what it looks like. But what we want to do is we want to actually open that, and we'll take a look at the raw metric view before we get into what the import looks like. So we're going to look at a simple metric view here, and this is a YAML format. So this is how you would interact with it within Databricks. So if you're working in Databricks, they do have a bit of a UI for editing this, but under the hood, you're actually creating a SQL view whose definition is this YAML. So ultimately, the thing that's deployed, the code that you're generating, is exactly this that we're looking at. And this is what you would work on in a Databricks environment, or if you're working in some source control environment such as Git, you would be source controlling files that look exactly like this. And a metric view has a few critical things in here. First is a version. Their spec continues to evolve, and we continue to track the spec. We make sure that even as they introduce new parts of this 1.1 spec, we continue to support those in our semantic bridge and for the import pipeline. The source is a single fact table that's defined in the metric view. This is a structural constraint of a metric view, that it's got this singular source. A source can be either a table reference, so this is an actual table or view that exists in Databricks, or it could be a query. We support all of this. And then there are a series of joins. Each join plays the role of a dimension in a dimensional model. Each has a name, it's got its own source, which can again be a table or a view, or it can be an embedded query. Each join has an on clause, which is saying how that's being joined to that one fact table, and an optional cardinality as well of either many to one or one to many. There's some additional optional properties. I'm not showing every possible thing you can configure in a metric view here, but each of these has a name. So we've got a product dimension in this model, we have a customer dimension, and we have a date dimension. And each of these is joined to that same source, as we can see. So all of these join back to that one fact table. This is a fairly strict star schema. Then we've got a series of fields that are defined. Each field, again, has a name and an expression. That expression can be either a reference to a column, or it can be a more complex SQL expression. And each of these can also have an optional display name. This was what would be shown to users in reporting tools, or what you would interact with from some end user facing client. Then we've got a series of measures. Each measure is defined, again, with a name, an expression, and the expression for a measure is some SQL expression that includes or that ends up as a scalar. So a sum would aggregate everything in the metric view by sum. You can also do more complex aggregations, for example, multiple different aggregates, or you could do arithmetic across these, and you can define more helpful metadata for client tools, reporting tools, and also for AIs if they're using it. For example, we can define a format string so that any client tool that knows how to speak to or communicate with a metric view would be able to use one of these format strings. Here we've got a total revenue being encoded as currency. Then we've later got this revenue versus budget, and it's got a percentage format string. And so we've got the ability to have these multiple measures that define the different aggregates and put a name to them that can be reused. So this is the structure of a metric view. And this should be very familiar to anyone who's ever worked with a star schema or who's ever done dimensional modeling. We've got a fact, some dimensions. The dimensions are called joins, but those are dimension tables. We've got some fields, and we've got some measures. These are the core building blocks of a semantic layer. Now, this looks very different from how a TOM model would look in TIMDL or in the TIMSL JSON serialization, but the same ideas are here. Even though a measure might look different in TIMDL for a Microsoft semantic model, it's not going to have exactly these properties. It will still have a name. It'll have an expression that would be in DAX instead of in SQL. It will have format strings and all of this other metadata. So the same concepts exist on both sides. The only question is, how do we take this YAML and turn that into something that we would be able to use in a Power BI or analysis services model? And that's where the bridge comes in. So like we saw earlier, this is an empty semantic model. This semantic model has nothing in it so far, but what we want it to do is be the semantic model of that metric view. So if we go to File, and then we come down here to Open, we have an option to import from metric view YAML. And so this is going to import the Databricks metric view into this tabular model. We'll browse and find that source on disk. This is the one we were just looking at in Notepad, and we'll click Open. We can provide the Databricks host, so this is the URL to your Databricks instance, and then also a path to a specific warehouse. These things are required for some of our query generation that we do in the M side, but you can put in placeholders if you're just kicking the tires. You don't need real values up front. These are only used later when you actually refresh the model, or if you wanted to interact with that Databricks instance. So for just kicking the tires, like I said, you can put in sample data here like I have. And then with a click of a button, it tells us the import is completed successfully. If there are any issues, those will be popped up here, and you'll be able to browse through and see what couldn't be translated and why, and then you'd be able to take action on those appropriately. And we can see instantly that we've got some relationships that have been added in here. And if we recall, we had those 3 different dimension tables: customer, date, and product. And here we see 3 different relationships in the tabular model. We've also got a number of tables that have been added in here. We've named that sole fact the fact table. And if we remember earlier, total revenue was one of the measures that had a format string. And we can see that even though the way that it's serialized is different, this is a currency format string with 2 decimal places of precision. And if we come back over and look at this in the metric view, that is exactly what we saw. It's a currency with exactly 2 decimal places. And so we've generated the correct format string that represents that. If we look at this revenue versus budget, that is using a percentage with some decimal places. And so if we come back over here and we look at revenue versus budget, this is all been translated into SQL, or from SQL into DAX. You'll note that the division is using DAX's divide function to be a safe division here. And all of the field references from SQL have been translated into field references within DAX. And we'll see that format string that we were just looking at. Again, this is translated automatically for you. So all of this rich metadata comes over with the model as you're doing this. So this is the basic workflow of a metric view into a tabular model. And what we end up with is a full tabular model that we can then continue to do things with. I could edit anything in here. If I didn't like the fact, for example, that revenue versus budget was using a divide, we're in tabular editor. So I could choose instead to use a division operator instead. That's totally fine. And now I've got this measure, and I can, like I said, do anything that I'd like within this model. I can add things to it, or I can make other changes, or I could publish this to Power BI and then use it directly with a Power BI model or with a Power BI report. Anything that would be able to talk to Power BI can now talk to this using the definitions that were from the metric view. So this is the sort of easiest and on-ramp to using the import workflow. But like I said, there are multiple phases. So maybe you want to do some work with that metric view before you get into that import. If you'll notice in here, we've got a few things like all of these field names have underscores in them. And some of these measures have friendly names, some of them don't. So if we want to deal with some of this, or if we want to work on that metric view before the import, that's also possible. So what I'll do is I'll actually do an undo. So I'm just going to do a Control-Z here. And that's going to undo the entire import because we're in tabular editor. Everything that you're doing can be done and undone. And what we're going to look at now is the C# interface to the semantic bridge. And this is where we can do a lot more advanced features of interacting with a model. So what we're going to do is we're going to start by deserializing. So deserializing takes a metric view, and here I've just got that same exact definition copied and pasted in. And what I'll do is I'll run this script. And when it deserializes, it's not doing the import. You'll notice that nothing appeared in the TOM model in the TOM Explorer yet. But we've got this metric view now in memory, the structure of it, and now we can interact with it. So one of the things that we might want to do is find all of those fields that we didn't like with the underscores. And so what this allows us to show off is a validation framework that we've got for metric views. So once you've got a metric view in hand, once you've deserialized it, we've actually got a number of helpful functions. I'll actually make this a little bit bigger, and we can make validation rules. Each validation rule is defining something that you want to check against the model. And here we're saying that a field name should use spaces and not underscores. And what we're doing is we've got like a little snippet here of C#, and this is saying for each field, we want to make sure that it doesn't contain an underscore. If it does contain an underscore, we flag it. And that's what that condition is checking. The rest here is just taking all of those diagnostics and putting them together for output. None of this is actually logic of doing diagnostics. This is just a friendlier way to show it. So if I run this, I'll actually get automatically flagged. We've got 5 issues based on these validation rules. And we've got the one validation rule. So that means we've got 5 instances of a field that's defined in the metric view that has underscores in its name. And what we'd like to do is make sure that these have friendly display names. And so what I'll do is a couple of different rounds of import, and then undoing that import, and then making some edits to this metric view, and then doing that import again. So like I said, we've already deserialized this. We have the metric view available. And what we'll look at next is how we can do an import of that in-memory model. So this is the metric view that we've already deserialized. And using a snippet like this, we can do the import. So this is going to do exactly what we saw before from the GUI, except it'll do it from a C# script. And so we haven't made any edits to that metric view yet. What we can see is that we've still got the underscores in the names. This is just showing how we do that import from a C# script. And this is where we can get into programmatic manipulation of the model. So what we'll do is first understand how we can get at some of the properties. So we've got a full object model for the metric view. Some of the things that you might be familiar with from C# scripting of a TOM model, where you can interact with all of the different properties and all the different objects in the TOM model. You can do the same thing with a metric view. So what we'll do is we'll say that we've got this metric view and it's already been loaded. It's been deserialized. So we're just going to capture that as semantic bridge dot metric view dot model. And so this is the structure of that model that we've just deserialized. And we can do things like look at the different objects in it. So let's say that we want to look at the metric view and we want to look at one of the fields. And then we'll go in here and one of the field names was customer segment. And then we'll just output this. And so this will show us that specific customer. The name is customer segment. So this is how we can get at those objects. So we can index into these by name, and we can get that object back out. Maybe, though, we don't want to look at the segment. We want to see, does it have a display name set? And so we can look at the display name property of this metric view field. And here we see that it's null. There is no friendly name set. And so this is showing us kind of what we want to be able to do as we're making this more friendly. We want to be able to go in and we want to be able to set that display name. So what we'll do is, in this example, I will do a quick copy and paste. And so that output is going to remain the same. But here we'll see we've got that display name. What we want to do is we want to set it to something nicer. So we want to set it to, let's say, customer segment without the underscores. And so now what we'll do first is we're actually going to be setting that property. And then when we do this output, we'll see what we've changed. And so here, that's showing how we can rename a single field. And what we want to do is we actually want to rename all of those fields. We had 5 different violations, if you recall. When I run this again, though, we'll see that there are 4 because I just did that one rename. But we've got 4 more things. So we've edited the metric view a little bit, but we want to do more, and we don't want to have to manually type out each of these. So here's where we can take real advantage of the C# scripting interface, is we can do things like a little for loop. And what we're going to do is we're going to loop over every single field in the metric view fields. And then what we're going to do is we're quickly going to just capture the old name. Then we're going to make a new friendly name by splitting on that underscore and removing it. And we're going to set the display name to be a name without the underscores, but with spaces instead. And so if I run this, we'll see very quickly all of the renames that occur. We see that product underscore name becomes product name. We'll see that product underscore category becomes product category. We'll see the customer segment. All of these get their nice friendly names. And so now, if I come back to this find underscores, this validation rule that's showing us all of those fields that had missing display names, if I run this now, we'll see there are no issues. And so now we've done deserialization of the metric view. We've run some validation, and we could run any suite of rules that we might want. You could come up with your own custom best practices and your own rules that you want to use in validation. Each of those is just a simple rule definition, and then you can validate with those. Then we've gone through and we've made a script. And with that script, we looped over all of the fields and we gave them friendly names. And then finally, what we're going to do is now that we've made those edits, we're going to do this import once again. And with this import, we'll see that we've got those relationships. We've got the same tables. But now if we look at those fields that were not the keys, each of these has a space in the name instead of that underscore. So we can actually load and programmatically manipulate these different objects in the metric view. So any property that exists in the metric view is available in that object model. So you can get at things like a measures definition, all sorts of stuff. So let's look at a different thing that we could access. So again, we'll just do a quick temporary variable, and we're just going to capture different properties. And what we're going to do is just show those. So this is showing how you can get at properties and then view them and also be able to manipulate them. So we'll do a quick output here of whatever variable we're capturing. And so we can look at, for example, the metric view measures. And maybe we want to look at that total revenue expression. And so we can get to the expression property there. And then when we run this, it'll show us what that expression is. That's the original SQL before it's been translated. And so everything that exists, all of those joins, you can get at as well. So instead of measure. We could also look at the joins collection, and let's say we want to look at the customer, and what we want to look at is the customer's on condition. So each of these things that you can get at and view, you can also edit. So you could use a C# script for any sort of automatic generation of a metric view, as well as these programmatic manipulations and validations, and using those diagnostic rules. The next thing that I want to look at is being able to do this in more of an automated fashion. So everything that I've shown here has been within Tabular Editor. And what we've got is, like I mentioned earlier, this is also available in the Tabular Editor CLI. And so what I'll do is I'll pull up a different window here. I'll stop sharing this one. And we'll pull up a terminal. So here I am. I'm now at a terminal. And we can see that I'm in a folder. This is the folder that'll actually be made available for you later to be able to work with different metric views. And so here, what we'll look at is a metric view that's a little bit bigger. This is based on our demo space parts model. And if we look at this, we've got a lot in here. This is much bigger than those couple of things that we were looking at before. And this is one really large metric view. And what we want to do is we want to say every time this thing is edited, for example, or maybe we want to do this as a Git hook. So every time something is committed, maybe we want to put this script into a CI/CD pipeline, for example. And what we could do is we could have every time a metric view is checked in to GitHub or to Azure DevOps, it could be automatically generating a semantic model for you. And so what we'll do here is very quickly, we will make a new model in this folder. This is going to be a new empty model that we're going to import the metric view into. So here we've got this model.bim. And if we look at the contents of that, it's pretty small. It's just the bare definition, no tables, nothing like that. We could also explore it with the TE-CLI. So I could do TE-LS of our model. And we can see that there's nothing in it. There are no objects to be able to display out of this. And so what we want to do is we want to be able to automate this. So I'm showing you interactive at the terminal, but this is a script that could easily run from anywhere, like I said, in automation pipelines or in a CI/CD pipeline, for example. And we'll look at a quick little script here that looks a lot like what we were just doing in Tabular Editor. We've got this semantic bridge. We're importing to Tabular from a file. We're going to point it at a specific model. That's the space parts sales that we just looked at. And then we're going to say whether the import was a success. And we're also going to give a quick statistics about how many things we imported. And if there are any diagnostics, it's just doing a quick little output here at the end to say what those problems were upon the import. So what we've got here is really what we'll do is a TE, and the script command is what we'll be looking at. And what we'll be doing is we'll be running this import, and we'll be running it with the model of this new model.bim that I just created. Ooh, sorry, wrong command. And again, this is something that could be checked into Git. This could be part of your CI/CD pipeline to automatically create semantic model every time the metric view is changed. And you'll see that even with a much bigger model, this one has about a dozen tables and multiple dozen columns and measures. It's still very, very quick. And so that was just a dry run. With the CLI, everything is a dry run by default. This time I'll make sure that since it was successful, I'll actually save that out. And so now if we do a TELS of our model, this will show us everything that's in that model.bim. We've got all of these different tables with the various columns and measures in them. If we want to look at that, if we want to look at the size of that model now, we can do a quick output of the model.bim, and we'll see that we've added a whole bunch in here. And we're not going to go field by field or measure by measure, but just showing that the semantic bridge is able to scale up to much larger models. It's able to support things like embedded queries. It's able to support more complex SQL as well. So you'd be able to run this at the terminal, again, whether that's you, whether that's an agent or an LLM that you're working with that would be able to use the TE-CLI to do this sort of thing for you, or if you're checking it in with Git and you're able to then have it be part of your CI/CD pipelines. So everything that we're looking at in Tabular Editor in the GUI is also available there in the CLI. I want to pop back over to the GUI, though, for just a couple of things. We'll share this again. We've got Tabular Editor. I want to show a couple other examples of potential problems that we might run into. So I've talked about these diagnostics and about the fact that we'll tell you if something was unable to translate. For demo purposes, I was very lucky that the person who prepared these demos made sure not to put too many errors in there for me. But just to show you what the import looks like when there is a diagnostic error, I'm going to add a measure that doesn't get automatically translated. And then with that, what we'll do is we'll see what the import looks like in that case. So what we'll do is we'll again undo in Tabular Editor. So we've got nothing loaded. I'm going to re-deserialize. So we're starting fresh. This is the metric view we originally looked at. And what I'm going to do is I'm actually going to introduce a measure into this metric view that is not able to be translated automatically. And so what I'm going to do is I'm going to introduce, like I said, something that can't be translated. Sorry, I'm just checking my notes really quickly here. What we want to do is we want to have a measure that doesn't translate cleanly, that we can't deal with all of the SQL in that. And so to do that, I'll show, just like we've been doing, rather than editing YAML by hand, I'm just going to edit one of those measures, that total revenue we were looking at before. I'm going to add a metric view window specification to it. And so when I run this, we're now editing that specific measure. Apologies, I forgot one part. So if we want to operate on the metric view object model, what we need to do is just make sure we've got that namespace in scope. So what we'll do now is run this without errors. And again, this is just editing that metric view in memory, but it's not actually importing yet. So we still have to go back over and do that import once again. And so here we've got that same import that we did before, working on this metric view that we've loaded. And here what we'll see is what happens when there is a diagnostic error. Oh, sorry, I need to actually show that. So when you run this import, if there are diagnostics, and this would be what you get from the GUI as well, will pop up this list of diagnostic errors that you can browse through. And what it's doing is it's saying that there was a specific problem in translation. This measure uses a window spec. So the window specs on metric view measures are not supported yet. They're actually in progress right now. I was working on them earlier this week. And it tells us exactly what's going wrong. I'll expand this out a little bit so we can read a little bit more of this message. We're saying that the measure is named total revenue, and it uses a window spec that's not currently supported. And it tells us exactly where that thing is so that we can go and look at it and understand exactly what's going on. But this is just a warning. It didn't fail the metric view import. It's just telling us that one part of this wasn't translated fully. And so now when I come over here, we'll look at that total revenue. And if we look at the expression here, we weren't able to translate that SQL automatically. And so whenever we're not able to translate something perfectly, we do sort of a best effort. And that best effort is not just trying to pat ourselves on the back. What we do is we make sure that we always give you the structure that existed in the metric view. So this measure, total revenue, did exist in the metric view. And we make sure that on the Tom side, this measure exists. We might not be able to translate every aspect of it, and that's where warnings come from. But we make sure that everything that existed on the starting side does exist on the ending side. So the structure always comes through. Some particular elements of that structure might not be translatable. For example, this metric view. And so we see that we've got the original window specification here. This is the part of the metric view that we weren't able to translate. So we put that through as a DAX comment so that you're able to then look at this and understand what didn't translate. And you could then either do a manual translation, or if you're using an LLM, you could ask it to help you. Or for window specifications specifically, you could probably just wait until our next release when we will be supporting these for automatic translation as well. These are typically used for time intelligence. As you can see here, this is looking at a trailing 3-month window of total revenue. So anything that doesn't translate cleanly ends up coming through as a comment, but we still preserve that structure, making sure that you're always able to get the structure through in there. So this was one of the last things that I wanted to show in terms of demos, but we'll pop back over for a couple of closing slides and then open it up for any questions. So if there's anything that you've seen that you had questions about or you weren't sure if it was going to be answered yet, please feel free to drop that into the chat or into the Q&A. And like I said, we'll have this the live Q&A at the very end here. So we answered the who, the what, the when, or the why, and the where. Now we're answering the when. When is the semantic bridge? And it's at all times, really. It was conceived in the past at SQL Bits a little over a year ago, and we had our first public release in January of this year. We had some private releases last year toward the end of the year, and we've continued to iterate and update it during each of our tabular editor releases. In the present, we support the metric view 1.1 standard. Like I said, not necessarily every property translates fully, but we have support in the object model for all of that 1.1 metadata. We have the metric view object model, allowing you to interact with programmatically, do validations, and do any sort of advanced manipulation of the metric view that you'd like, whether in tabular editor or in the TE-CLI. We've got the validation rules framework with a number of built-in validation rules to make sure that it is a structurally sound metric view and that you can enhance with your own best practice rules or your own validations that you'd like to run on any metric view. And we've got that full scripting interface to be able to deserialize, interoperate with a metric view, make changes to it, make updates to it, and then finally import it. Or you can always re-serialize that model. So you can make some changes in a TE script and then serialize that metric view back out. It's actually a pretty nice tool for bulk updates of metric views in that way, similar to C# scripts have always been for semantic models, for tabular models. And we've got SQL-to-DAX translation based on our own SQL parser that is continuing to improve with every release. In the future, what we'll do is enhance the GUI. That will have more interactive UIs for some of the things that I showed you in C# scripts today. We'll have, like I said, window measure translations and continue to expand our support of different constructs to translate from a metric view. And of course, we'll continue to track the metric view standard as Databricks continues to put more things into that v1.1 standard. We've got some resources here. And these links will be, like I said, the presentation is available afterwards, so you'll be able to get to these links. We also dropped the first 3 of these earlier today, or earlier in this presentation, and we'll add the semantic model docs and metric view docs here. All of these tell you about the semantic bridge, give you documentation and examples of how to use it, as well as some starting metric views that you can use if you don't have any of your own, but you still would like to try out the tool. We've got the semantic model docs from Microsoft, and finally, the metric view docs from Databricks. And with that, it's time for questions. I see that we've got a couple queued up here. So again, if you've got any questions, make sure to ask those and we'll curate some of those for live answers. But the first question that I've got here is from Remco and asking, saying that they're in a selection process between Snowflake and Databricks. And will the semantic bridge also become available for Snowflake? We don't have a roadmap yet specifically of platforms that we're going to support in the future, but Snowflake is probably going to make that list. I can't make promises. Like I said, it's not on the roadmap, but they seem to have some of the most momentum right now. And certainly as a member of the OSI standard, they're probably going to continue to invest in their semantic layer. So I'm interested in it, but we don't have a roadmap yet for those future platforms. Just keep watching us and we'll let you know as soon as we've got something we can talk about publicly. I've got another question here that says, what happens if I import 2 metric views that both have a shared dimension table? Does it create 2 copies or deduplicate natively? So right now, when you import multiple metric views, each metric view is its own isolated import, and everything in that metric view comes over. So right now, you would get 2 copies of dimension. And in the future, what we'd like to do is do that deduplication. That's one of the enhancements that we've got on the backlog. No public roadmap release date for that yet. That's one of the enhancements that we'd like to bring on with some of the GUI enhancements to be able to select specific tables and do that deduplication for you. So right now, if you import 2 different metric views that have the same dimension, you do get 2 copies of that dimension. In the future, though, we'd like to improve that. Another question, this one from Rodell, asking, is it possible to rename from fact to something like fact orders, or can we apply a custom name before we do the import? Right now, that's not tunable at the import tier, but it is really easy to change that after the fact. Or if you're using C# scripts, you can simply look for the table that was imported. It will be named fact, and you can just do a rename as part of your C# script. So again, that's something that would come as part of the GUI improvements in the future, but right now that is just going to be named fact as it comes through. We've got another question here from Mary asking, do changes made through the semantic bridge propagate back to the Databricks metric view, or are they limited to the Power BI semantic model? So if you make changes to the metric view itself, like I said a moment ago, you can serialize that back out. And I think this one is actually worth a quick look. So I will pop back over to my tabular editor window here. And we'll share this window. And you can actually see about the prior question, I did 2 imports in a row. And so this is where you can see that each table got imported twice. If you import twice, you get 2 copies of the table. Like I said, we'll work on duplicating that as we improve the tool further. But the question here was, do the changes made through the semantic bridge propagate back to a metric view? So when we've got this deserialized model, and then we make some change to it, and so what we had done is we deserialized this, and then what we did was we added the window specification to this metric view. And so what we'll do now is we want to reserialize this. So I'll do a new C# script just so that we've got this as an isolated snippet. And we'll do semantic bridge metric view serialize. And so serialize is going to give us a string here. And so we'll capture this into a variable just so I can display it. But there is also a save option, and saving would put it into a file. So what we'll do is we've got this, and then we'll do a quick output of that serialized string. So again, what we did earlier, this is still using the same state as we had before. We deserialized, and we saw that total revenue from the original was like this, without any specification without any window spec. And then here, later, we had added this window spec to total revenue. And then here, what we're doing is we're serializing. So all of those things happened in this one session. And what we'll see here when we output, we'll get a string that is the serialization of this metric view. And right here for total revenue, we'll see the original definition, but we also see that there's this window specification below it. So when we made the change to the metric view in a C# script, we serialized that back out. So any changes that you make to the metric view are savable. Like I said, here we used serialize just so I could show you this string, but you could also use the save method instead. So there, what you would do is, we're not going to have anything to output here, but we'll serialize it to a path on disk. And we'll change serialize to save. So save takes that path that you're going to put it out into. And then we'll pop over here to Notepad. And so here is, again, the original that we were looking at. But I'll do a quick open. And we had named it new.yaml. So if we open this new.yaml, again, we come down here to total revenue, we can see that thing that we added in the C# script. So any changes you make to the metric view, you can export back out very easily. Like I said, this ends up being a really useful tool for bulk edits of metric views as well. Now, you might have meant if I make an import and then I make some changes in the semantic model. Right now, we don't do the tabular model into a metric view. So if we did something like this, we did this import once again. This is the window function that doesn't translate. If we did this, and then I came in here and I said, I want this fact, going back to another question, I want to rename this to fact orders. And then maybe what I want to do is, I actually don't like gross margin. I just want to name this margin instead. So now I've done some renaming to the tabular model. I can save this as a tabular model. I could deploy it to Power BI and so on, but there's no path to get right now to get any of these changes to the tabular model back into the metric view. So any programmatic changes to the metric view itself, yes, those you can get right back out, and you would then be able to deploy them. But any changes to the Microsoft semantic model, the TOM model, those don't propagate into a metric view. All right, and then I think I may have been begging for this question during showing these. The last question I've got here is from Adam, asking, moving from metric view to PBI is great. Are there any plans to go the other way, creating metric views from Power BI models? So this is something that we've talked about, and bluntly, it's not as high on our priority list because metric view can't support so many things that are common in tabular models right now. A tabular model, for example, can have 2 fact tables. This is not yet supported in a metric view. So the question then becomes, how do you export a tabular model that is, the structure of it cannot be represented in a metric view? And you run into those a lot more frequently going from the tabular model to metric view. So realistically, there would be so many trade-offs and so many limitations that it's not as interesting to us yet, because we wouldn't be able to give you a useful artifact on the other side. As the metric view gains more maturity, we're certainly looking at multiple different platforms and different directions of translation. Like I said at the beginning, this is really a framework. So none of this is really hard-coded to metric views or hard-coded to tabular models. Right now, we're looking at it as an import to tabular functionality because, again, really bluntly, the other platforms support much less than the tabular model does right now. So right now, we're looking at it, like I said, as import to tabular more than the other direction. And then we've got last question here from Marcus asking, is the DBT semantic layer support on the roadmap? And that is, again, we're looking at other platforms. Questions like this are actually really useful. If you've got concrete use cases or asking us here and talking about it, we really want to go where our user base is. So wherever there's the most demand for another platform, that's realistically the one that we'll be prioritizing next. Right now, we're still working, like I said, on improving some of the pieces of the metric view workflow, including building a better UI and things like that on top of it. That GUI would absolutely be shared. And so that would be an investment in other platforms as well. And once we've got sort of that fully stable UI base and some of the improvements that we've talked about earlier today, then that's where we'll be looking at these other platforms. So please continue to give us this feedback. Whichever platforms you find interesting are really, honestly, the ones that I find interesting. So we'll be looking at those other platforms as we continue to move forward. And with that, I think we'll get done with that screen share. And the last thing that I have to say is simply thank you to everyone for spending some time with us today. Thanks for engaging in the chat and asking those questions. And like I said, everything from the webinar, we'll make those materials available to you after this. So I still have to finish putting some of these scripts into into folders. And so we'll share those details with you later. But all of this will be available. You'll have the slides and all of the materials that we saw today. So thank you so much. We really appreciate everyone spending some time today and engaging with us. It's been a great way to spend about 45 minutes. I hope you have a great evening, afternoon, or rest of your day, depending where you are.